tables, and look at that shell. What the statistician is expecting from this table. Okay, so this is a subject disposition by treatment. So they want to consider only the safety population subject, and this yellow color highlighted we can call it as header part, and this blue color we can call it as body part. Okay, header part you can see drug A, how many subjects are taking the drug A in the safety population we have to represent in the place of XX, and here how many subjects are taking B treatment we have to display here, and C treatment, D treatment, and total treatment. And in the blue color panel each and every condition met how many subjects taken by the drug A. For example, subjects withdrawn is there. So drug A we have drug A subjects we have 10 subjects are withdrawn. So the 10 number we need to represent here and along with the percentages. Okay. Here programming nodes you can see population they want to consider as a safety population and inclusion exclusion criteria. So it should be no TRT01P should not be missing in the enrollment. So they want to use the enrollment flag. So subject withdrawn purpose you can use the end of the study status variable equal to discontinued, and reasons you have to use this variable to display all the reason. Percentage should be calculated this small n divided by capital N into 100. This we can call it as small n, and this small n divided by capital N into 100 it will display the percentage. This is the information they provided. So we have to do mathematical calculations and get the counts. After that one, counts and percentages we have to display. So any table, if they mention header part, so first we focus on the header part, this n. This n we can call it as capital N, big N or big N. Okay, capital N always any table we have to take it from the data set ADSL. So subject level data set. So we can take this information. Okay. So let me start the programming. So header part and libraries you can take as it is. Just paste it here. So this is a table. Will starts with the T and so 1411. Okay. So this is a table. And today is 3rd April. Save this program as okay. Let's run it. So in this, the first we need to focus on the capital N or big N count, any table. So capital N or big N counts derivation. Okay. So always we have take from the ADSL dataset irrespective of any table. So you have to filter the population and take the number of subjects who allotted to the each treatment. Okay. So first filter the condition data ADSL underscore capital N, right? So set adam.adsl. So we have to first filter the safety population. Safety population purpose. So ADSL safety population. So they haven't mentioned any variable. You can simply go and check with the ADSL. We have already created the listing. So safety population, the variable is this one. Okay, you can see safety population flag. So this variable equal to Y related observations only they want to consider. Safety population subjects only we need to take, that means what? So only who are eligible or who are already having the flag with the safety population flag. So we include only that subject in this table. Okay, so that is why every table you need to check which population they want to mention. And safety population, so always safety population we use the planned treat, not planned treatment, actual treatment they use. So here I think they missed out. Any safety population, generally we go with the actual treatment, not the planned treatment. So actual treatment we need to take. So let me check whether any actual treatment is there here. So here planned treatment only there. So here TRT01 there. So there is no actual treatment in the dataset project. So what we is there? The actual treatment also there. Simply we can keep subject and actual treatment numeric version, actual treatment planned version, actual treatment character. A nothing but actual treatment. If it is there, P planned treatment. So simply I filter the data. So now you can see first subject belongs to the first and third subject belongs to fourth subject two, three like that. Okay. So now I just want to count. Okay. So just want to count how many subjects are belonging to the each treatment. Simply I using the ProcSQL. So create table. What we can give the data set name as TRT. Select. Just I am treatment wise calculation, numeric wise, character wise. They are counting the distinct use subject ID, unique subject ID as we can give denom as a variable from which data set ADSL underscore capen. Okay, group by treatment wise and order by also treatment wise. So we have to sort and we have to group treatment wise. Now you can see the data set which is created TRT. Yeah. So first treatment, how many subjects are allotted? Three subjects. Second treatment, three subjects. Third treatment, three subjects. Fourth treatment, two subjects. 3 plus 3 plus 6, 9. Total 11 subjects are there. So whenever you want to represent in this table, so here 3 and here 3, here 3 and here 2, and it should be 11. But how can we get this 11? How can we get this 11? So we have actually treatments like 1, 2, 3, 4 there, but there is no fifth treatment. So what we do, simply you can add one patch of code here to get that information. Simply write one output here and again TRT01A equal to 5, TRT01A equal to all, and you can write one more output. Now you run this one, you can see there is a fifth treatment added, that is sum of all this one. Okay, simply we are adding each and every row, we inserting this all treatment. Okay, so that whenever you are calculating this one along with the individual treatment, this treatment wise also counts you will get like this. Okay, so if you are a table having this treatments along with the all treatment, simply we can do like this, just add the outputs and add the fifth treatment and this one. For example, it is a three treatment, you have to give the fourth number. If it is a two, you can give the three number. Okay, yeah. So now we get the counts. We get the counts here. So how we are going to represent that in this place? So what I do, simply I converted them into the macro variables. Okay, select. So this variable. So by using the into class, begin 1 to, so begin 5 treatments, right? From which data set? TRT data set. Okay. So if you want to check how the macro variables are resolved, begin 1, begin 2, begin 3, begin 4, begin 5. Okay. So just checking whether it is resolved as a macro variables are here. You can see begin 1 3, begin 2 3, begin 3 also 3, begin 4 2, begin 5 is 11. So these 5 numbers we are giving begin 1, begin 2, begin 3, begin 4 and begin 5. So whenever you want to use this number or whenever you want to print this number, simply calling that macro variable reserved as this count, and it will print the place where we you know uh, represent. Okay. Yeah, header part was done. So at the proc report time we can call this macro variable to print that information. Now somebody is posted something.
Yeah, we can use this code also, right? Directly.
Yeah, you can use direct code also fine. Just giving some elaborated manner so that uh, so this
Yes,
treatment
yeah.
data set I created, I just show you so that numbers will seen. After that one, you can convert them into the macro variable. Otherwise, directly converting macro variables also fine. Okay.
Thank
So next coming to the body part. Body part. Okay. So body part. So based upon the table, which data set they are going to use. So this information there in the ADSL itself. Okay. So for example, it is the adverse event data set. The body part is taking from the adverse event. Capital N count we always take from the ADSL. So body part first, what we do? So we have to take the ADSL data set. Yeah. So ADSL data set, same data set I just taking here because the body part information also there in this one. So ADSL, so I just give body part and the variables which we want to use. So treatment related. Next, this planned treatment purpose. Okay, so sorry, this is the planned one only. Yeah, so this one planned treatment purpose, they use the TRT01P, P and PN. And this enrolled purpose, they use this enrollment flag. And withdrawn purpose, they use this variable. And the reason purpose, they use this variable. Okay.
Uh, So, is it mandatory to use the planned treatment?
Yeah, because here they are asking subject plan treatment counts and percentages. Okay.
Okay.
So
So,
that is why we use this variable. Okay.
okay.
So
I'm asking in general. In general, there is a no rule, right? That it should be the planned treatment, or is it there is a rule that it should be planned treatment?
yes, safety population any table. So the Kaplan column, the Kaplan variable should be actual treatment only.
Actual
Okay.
treatment. Okay.
Yeah. So apart from the safety population, we use the planned treatment or actual treatment based upon the starts decision. But
Okay.
any safety table, So the blind rule is we have to use the actual treatment. Okay.
Okay, okay. Got it. Thank you.
Yeah. Here ADSL underscore body. So each subject having two record, one record belongs to the first actual treatment, one belonging record to the all treatment. Okay. So now the first one, the first row we are going to calculate. So how many subjects are allotted to the planned treatment, each treatment wise. Okay. So how we are going to calculate? Simply, I just take this as code. So subject planned treatment. So I just given the data set subject planned treatment SPT like that. So here, so we want to print this text. So this text I'm giving the variable name as some population. Okay. And this variable length I'm giving as 100. So I just give as one as ORD. Why? Because so we need to print this line in the first position, right? So as per this one, first position. So one I am giving and count of use of JD from so as I'm giving small n. Okay. So that's the capital N, this is a small n. The condition is here to get the plan treatment what they mentioned TRT01 must be missing, must not be missing. So TRT01 PN not equal to missing. Okay. So now you will get the counts of the plan treatment, each treatment wise. Then this TRT01 PN is there, right? TRT01 PN is what is the issue? Let me check. Oh, the data set name is ADSL underscore BOD. Yeah, so subject plan treatment. So first treatment, second treatment, third and fourth and fifth, the subject plan treatments counts are this one. Okay, this is a population. This order we are giving, and this as per the plan treatment, these are the counts. Now the second row is subject enrolled. How many subjects are enrolled? So simply copy this code, paste it here, and the subject enroll data set, and this is the text we are going to print, and this we can give second, and the condition here enrollment flag should be y, so equal to y. Okay, so now the subject enroll, so this is the count for subject enroll each treatment wise. So third row is how many subjects are withdrawn. Yeah, let me copy this code and paste it here. So subject withdrawn, and this is the text, and you can give the 3, and the condition is EOSTT equal to discontinued. Okay, so we can see now subject withdrawn. So there are first treatment who are taken, subject withdrawals are 3, second treatment taken subject 2, third treatment taken subject, one subject is withdrawn from the study. Total 6 numbers are withdrawn out of 11 subjects. Okay. So they want to print the reason. Each subject, the 6 subjects are withdrawn, right? So they want to see the reason. You can see here the reasons are like this: withdrawal by the subject, death, and something. So how many reasons are there? Each reason wise we have to calculate. So here they mentioned reason 1, reason 2, like that. As per the data, how many reasons are there? That all the reasons you have to populate. So withdrawn reason, subjects withdrawn, reasons wise counts. Simply you just copy this one, paste it here, subject withdrawn, reason. So the reasons we have to display here. So that is why that variable you can mentioned as pop, so that how many unique observations are there, that unique observations are allotted to this pop, and you can give the next order, and same thing, and in this the reasons wise you need, right? So that is why you mentioned that variable also in the group wise. So SVR data set, subject withdrawn results, you can see first treatment death, subjects are 2, withdrawn by patient from the study 1 subject. So total 6 subjects, right? 3 subjects are death, 3 subjects are withdrawn from the study. Okay. Likewise, reason wise counts you will get. Now all the sets completed, we have to set all the data set together. Final underscore counts, set the subject. The first one is what? SPT, subject plan treatment. Next, subject enrollment flag, subject withdrawn, subjects withdrawn reason. Just set up all this one. You can see the data like this. So plan treatment first, next enroll, next withdrawn, next reasons for a withdrawal. Okay. So we are getting the counts, but actually what they are asking, counts here and percentages also here. So how the percentage, for example, here you are getting 5 subjects, and here you are getting 10. So this 5 divided by 10, you will get what? 50%, right? So 50.0 we need to mention. Yeah, sorry, it got disconnected. Uh, yeah. So hope up to here you already able to hear, right? So this count part was done. Now the percentage calculations. How the percentage calculations were doing? Small n divided by capital N into 100. We are going to get the percentage calculations. Okay. Am I audible, right?
Yes, sir.
Yeah. So small n counts are here. Capital N counts are in this data set. You will see each and every, not this, in the TRT data set, you will see this is a capital N count. So now this small n divided by this capital N into 100 will get the percentage. So for that purpose, what we do? So we have to merge these two data sets so that both the variables are in side by side. TRT01 AN and run. So now final percentages. So merge your data set with the TRT data set by treatment and run. So there is a internet issue due to heavy rain here. Sorry. Yeah. So once we done this one, final underscore PCT, you will see this is a small n and this is the capital N. Now small n divided by capital N into 100, it will give you the percentages. Okay. So simply we do the percentage calculation. PCT1 small n divided by capital N into 100. You will see the percentage 100%, 66.6, like that you will get. So how they want to represent here? First counts and open bracket percentage is up to one decimal. So we can write the percentages in that format. Percentages. So put off this small n, like some four dot we can give, and just open the bracket and put off this PCT1 up to one decimal. So 5.1 and just close the bracket. You will see the PCT now. Oh, some error. PCT1. Now we can see the PCT data set count, open and closing bracket percentages. Fine. But here they are asking treatments are in a separate column wise. Here the treatments are in under one column. So to get this information into as per the mark shell, what we do? So we have to transpose the data set data equal to final underscore PCT out equal to final underscore PCT2. So by variables are here. So this order and population should be by variable. And which one we need to transpose? TRT01 AN variable and where variable, which variable under this one, PCT. Okay, so we have to sort before the transpose by variable and run. So now you can see the final underscore PC2 data set. So this is the order, subject, plan, enrolled, withdrawn, and the reasons you can see. So first treatment, second treatment, third, fourth, and fifth. Okay. So we are getting the table as per the shell, but few modifications are required still. That is, wherever the missing values are there, we are going to replace that value as 0 because there is no subject. That is why we have to replace it as a 0. Data final set final underscore PC22. If underscore 1 equal to missing, then underscore 1 equal to 0. And if it is a 2, 3, 4, 5. So 2, 3, 4, 5. So why I'm giving this space? Because to set the alignment of the 0 as per the numbers. Because we are giving 4 data, right? So that is why I just given the spaces because to get the alignment as per the other numbers. So here you can see the final. So 0 should be aligned 1. Okay, so if you see 0 should be aligned. Other you are directly giving the 0, it goes as left alignment. Okay. Now what other? So here you can see reason they give some space here. So that is why whenever we are giving the reasons, okay, we can give here itself. If the ORD equal to 4, then population is 1, 2 spaces I am giving concatenated with the pop. Now you can see there is some space here. Okay. And anything we missed out? Nothing. So directly we can print the information into the RTF file like listing how we are printing. So similar way we are going to print this information. Simply we call the titles and footnotes and this part. Yeah, title 3 is, this is the title 3. And footnote is table 2 underscore 1. So we can give anything. This was a 14, 1411. And the data set name is final. What are the variables we are going to display? So ORD, pop, and 1, 2, 3, 4, 5. So 1, 2, 3, 4, and 5. Now we have to define each and every variable. Define ORD order, but we are not printing because the mark shell is not asking this one. And population we have to print. Simply we just copy, paste it here, and you just mention the population. The text is, the label text is population. We can give the cell width 49. And next 1, 2, 3, 4, 5, right? So simply copy, So underscore 1. So how they want to represent? Drag A, go to the next line, and here they want to print like this XX. So XX place we need to resolve the number. Okay, we will show how to resolve that number. And here you can give the 10 first treatment, and second, and third, fourth, and fifth. So 2, it is B, and it is 3, it is C, it is 4, it is D, and it is 5, all. Okay, and above one line, below one line, and close the output. So if you run this one, you'll see how the output is going to generate. Yeah, the output is going generate. So this XX place we need to resolve the numbers. So we already created one macro variable here, right? So at the top here. So begin 1 to begin 5. So now we are calling this macro variables in the proc report section to resolve this as a numbers. So in future also, if the counts are changed, automatically the numbers are changed, the macro variable numbers are changed, that numbers only we are printing here. Okay. So if you are directly giving some numbers in the place of XX, in future the data might be updated. That time also you need to update. So if you are creating the macro variables and passing this macro variables in the proc report section, it was resolved as a numbers like this: 3, 3, 3, 2, and 11. And one more thing here, we have given the space, but if you everything left align, it will go as a left alignment. To overcome that issue, as it is what they given in the data set, as is equal to on, so that if you are giving the spaces, that spaces also printed here. Now you can see it's spaces we are giving, right? Spaces. Now the counts you can cross check, plan treatment, so everything, enrolled, everything, withdrawn 3, 2, 1, total 6 subjects. So 6 divided by 11 also you can check the percentages, and the reasons, 3 reasons are there, 3 reasons are withdrawal by patient from the study. So this 6 should be matched with this reason, because subjects withdrawn 6, the reason should be also 6. Here you can see this treatment, subject withdrawn 3, 2 and 1. Subjects withdrawn 1, so 1 reason. So there is no subjects withdrawn from the D treatment, so 0, 0. Okay. So this is a safety population, and the populations are like this. So in future the reasons were increases, automatically one by one reason it will print, because we are using that variable containing all the unique type of observations are going to print in the withdrawal reasons. Okay, so this is a mark shell, and this is the process of creating counts and percentage related table. Around 60% of any clinical trial from any clinical SAS project. So you will find 60% of the counts and percentage related tables only. So they will put the treatment information, and they given some rows. The rows wise they are expecting counts and percentages of subjects. Okay. So first you need to calculate the capital count, then go to the body part, and each row we have to calculate the counts. Later we have to derive the percentages and display and transpose and write in the proc report section by using the data set. This is the process. So yes, first time itself little bit confusing, but this is the way to do any type of table in the project. So if you are assigned any table, you have to follow these steps one by one. So you can synthesize, or you can use the different procedures also, no issues. Here I am using SQL. You can also use FrogFreak or other procedures also fine. Okay. So this is easiest way to generate a table with the counts and percentages with the logics. We have to understand what is this percentages. You can also manually calculate also 3 by 3 100%, 2 by 3 66.7%. Like that also you can calculate your percentages and numbers and confirm that okay, this table was accurate, and release for the validation or QC. Okay. Anybody having any doubt on this table, any step, you can ask me. I'll explain once again. Hope everything is clear.
I think we might to go through this particular recording one more time so that we might get
Yeah,
little bit more clarity, frankly saying.
yeah, should be definitely because yeah, first time the table looking bit complex, I know, but there is no other alternative way to practice because listings are straightforward. I already told tables are little bit tricky. So if you understand the tables, then only you can able to answer any question from the interview point of view. And whenever you are joined in any company, the ultimate work is to TLFs and ADAM and SDTM only. So if you know the process of the table, you can do any type of table. Okay. So once you
Can
see
you
that, yeah,
can you take me to that portion where we calculated the frequency part in the
yeah,
code?
here SQL code I use. So count of distinct use sub JID. This is the count I have created by using this condition. Okay. And I am
Uh,
giving this count information as a variable n, small n. Okay. So you can also check. So that what happened, download my code and step by step run, execute and see the numbers. Okay.
and do we need to give this group by and order by? Do we need to use both, or we
Yeah,
can
you
use order
can
by?
if you use both one that is more effective because order it is sorting purpose and if it is group or giving so multiple observations are there in the treatment so it will group. So without group also it will okay but sometimes it will give a problem. So that is why instead of that one you can use this two also no issues. Okay.
Okay.
Yeah. Yeah. And so today I'll give some interview questions as well. Yeah, we have completed 15, right? So 16 onwards. So we'll see the 17th one by one. So we already shown data set with the zero observations. We have seen the listing of AE. So how to display that one, right? So this question will ask you in the interview. So if you are a data set having the zero observation, that means after filtering your data set with your proper condition, so you are getting the zero observation, how you are going to represent that information in the RTF file. So for example, undifferentiated there. So so the zero observations, we already seen this one, right? So ampersand number of observation you need to calculate first. So if it is a zero, so no observations are in the period. If it is a greater than one, so you need to represent general proc report section. That is what we are done in the AE report. The same thing you can explain. So whenever it is a no observation, so you have to generate your report. No observations in the report, either table or listing. So once you've done, just simply count the observations present in the data set and create as a macro variable that number. And if it is a zero, we write one report. If it is a greater than one zero, so we write a normal proc report. Okay. And a baseline. So we already discussed the base type variable. So now the baseline. Baseline definition is what? Is the last measurement prior to the administration of the first dose of study medication. So, for example, today is the subject is taking the drug, our oncology drug. So, before screening has three records. Which one has the latest and prior to our study treatment? That value we can pick as a base value. How the change? Our actual value minus base value will get the change. So, for example, here you can see the first subject. So ALT parameter. So screening 13, day 1 15, week 1, week 2, week 4 has this value. So the day 1, the subject is taking the treatment. So here you can see the treatment start date is on 3rd January 2018. So here 3rd January 2018, 9 o'clock, the lab was collected. 9/1, the subject is taking treatment. So we have two records before 9/1. One is 9 o'clock and another one is 1st January 9/20. These two records are there, which is prior to the treatment start date. In these two records, which one is the latest one and closest to here? This day one we can consider as a base value. This 15 value we can consider as a base value. Second scenario, second subject, or you can see 101 basophils. So here you can see 9/1, same 9. So this 2 we can consider as a base value. In this 3, you can see there is a missing value here. Okay, so we cannot consider this missing value as a base value. We can go with for the above value. So here you can see the last measurement prior to the first one. So we should not be non-missing value. Okay, so in this WBC cases, this subject, the base value is 9, not the missing value. So in case two missing values are there, so we can't do anything because there is no other value below before the screening record. We can keep as a missing record as a base value. And here you can see the WBC. So 9, 9, two records are there. Okay, 6 and 2. So in that cases, last record we can take, like, so no, no, this is date is different, right? This 2 we can take as a base value. So definition of base value is what? So prior to the treatment, so what are the values are there? In that value, which one is the latest and closest and non-missing value? We can consider that value as a base value. Okay. So you can write the coding like this. We can explain the coding later. And here also some example, which value we can consider as a baseline flag. That value we can give as a Y. Okay. And this is a same. What I explained, just, programmatical base and change and etc. And next here. So what are the ways to create a macro variable and what are the macro debugging options? So we are dealing with the so many macros day to day life. So that time the basic questions asked by the interviews people are how many ways to create the macro variable. Here how we created the macro variable, which method? By using the procSQL into class method we create the macro variable. That is a one of the method. And what are the other ways to create? So first one is percentage let statement. So percentage let, and if you are assigning anything, so if you are calling this macro variable, that macro variable resolved as this statement. So percentage less DSN equal to clinical. If you are calling this as ampersand DSN, that was resolved as a clinical. This is a one method to create the macro variable in open code is percentage let. Second method is positional parameter. So what are the macro variable you assign directly DSN and OBS? Whenever you are calling that macro, what are the information you pass directly automatically it was resolved as DSN equal to clinical, OBS equal to 10. Should use according to the order in case of positional parameter. In case of keyword parameters, so like this, you need to mention that thing DSN what, OBS what. Okay. And in case of into class method, just now we seen. So by using the procSQL method, into class method, we create the macro variables. And one more method is calls input method. So calls input method, by using calls input, the particular macro variable name and that variable you can assign, so that that variable wise, that what are the macro variable you created. So here name counts name. So name 1 to name 19. So it was resolved like this 1, 2, 3, 19 names are there, right? So each one it was resolved as one macro variable. And next macro debugging options are mprint, symbolgen, mlogic. And so this we can you already learn in your base and advances, I hope. So mprint, symbolgen and mlogic. What is used for what? So mprint is used to print the base SAS code. mlogic will use to print the details of the execution. Symbolgen nothing but print the value of the macro variable. So symbolgen used to the, if you are using some macro variable that was resolved as what, and mprint if you are writing. So whenever you executing any macro, if you want to see what is the base as code which is executed in that macro, it will print. So mlogic nothing but the print the details of the execution, step by step execution, what happened in the programming. So it will execute. And n merror and serrer use it to warning messages. If you don't want to print that time merror, serrer message if you want to warning messages when you invoking a macro variable. Okay, so these are not useful, because if you are writing this one, the valid errors are, it was not showing. So that is why we generally not use errors error, but mprint mlogic symbol gen we write about the macro, so that we can see what is happening in the macro while executing. We can clearly, whenever any bug or any error encountered while executing the macro, we can easily figure it out. Okay. So next, decimal precision. Okay. So what happens sometimes, decimals here, the mark shell, if they clearly mention how many decimal they want to print, so we can directly print. So some cases what happen in some complex studies, so they want to clearly mention how many decimal they want to print for each and every lab parameter or other parameter. So here one of the example, WBC, you can see basophils, WBC, basophils and ALT. So 101 and 102, the WBC's values you can see. The screening record, the value is 9, 9.1, 3.62, 4.13, and the last week for value you can see having the three decimals, 4.22233. Three decimals are there. And here you can see two decimals, no decimal, one decimal, one decimal, one decimal. So as for this one, whenever you are creating any statistical report on the WBC, you need to consider which one having the highest value. That decimal you taken into the consideration. Okay, here three decimals are there, right? So three decimals are assigned to this one. So as per one SAP, so they are asking you to mean and median should be one more decimal of the original data. In this case, what happened? So mean and median, we have to add four decimal, because our raw value is three decimals, right? We have to represent the four decimals, and minimum maximum same number. That means three decimal. Standard deviation, two more decimal, means five decimals we have to display. So WBC parameter time, you have to take a highest value, and as per the SAP, so mean and median plus one decimal, minimum maximum same decimal, standard deviation plus two decimal. So we have to take like this maximum number, and whenever you are going to represent in the table, uh, yes, let me show here. You can see WBC. You can see mean is 5500. That means four decimal. Standard deviation. You can see five decimals. Median four decimal. Minimum maximum same decimal. That means three decimals. Okay. I'll provide you the code, but the logic behind. So whenever you go for the interview, they ask you how you people are considering any decimal precision. So decimal precision mentioned in the SAP, if there any specifically they want to keep these many decimal, they want to be displayed in a table. So they mention like if the original data having some decimal, so one more adding the decimal. So first of all, you look the original data for the particular parameter, how many decimals are there, maximum decimal you take into the consideration, and we can display as per the decimals. Okay. And here you can see the hematology, three decimals, four decimals, like that. So WBC count, you and go check with the data, and how the WBC you can see this one, and this is the three decimals are highest. So four and five you need to give. Okay. So coding also I just mentioned in this one. So now it is not useful at the moment. Whenever you go with practically, so this code will helpful. Okay. So theoretically, you should know what we are going to do. Later, programmatically, you can apply the logics. So next, the imputation rules in the ADA. So whenever you see some partial dates are seen in your data, so the starts people were asking you to assign some dates to that partial dates. Okay. So in that scenario, the adverse event most of the times you will see the partial date. The date part is missing, month part is missing, year part is missing, happen in the adverse event data collection. So that time your statistician is telling that so to input some values. So in the interview people they ask you, can you please some example in your study where you have done your imputation in the adverse event. So how we are doing. So first of all, you can see the adverse event start date. This is a complete date. Why? Because so year part is there, that is 2018. Month part is there, first month. Date part is there, this one. So RFST did nothing but treatment start date. So 2018 March 2nd, if the subject is taking the treatment. So for example, if the adverse event start date is like this, only the year part and month part is there, the date part is missing. So that time, what the stats will do, so first you have to separate it out year part, month part, and day part. Here the day part is missing. So here the treatment start year, month, and day. So this is a treatment. So in these cases, both the years are same. 2018, 2018. So and the month is equal to this one. You have to give the 15th date. Okay. So year is same cases. Okay. So year is same cases. Month is below this one. Third month, here the second month. So year is same, month is below. So they are asking you to assign the 15th day of this month. Okay. If the year is greater than, okay, here the fourth month and here the third month, in that cases they are asking you to assign the first day of the month. Year is same, month is same cases, they are asking directly what the day the treatment was taken, that day plus 1 they are asking us. So that what happened, 2 will be 2 plus 1 3, we have to add and create this one. So whenever the date imputation done, so you should populate the DTF flag as D so that we know, okay, date imputation was done for this record. So three scenarios. Year is same, the month is below, we have to add 15. Month is above, we have to add the first day. Month and day, month and year is same, you have to add the day plus 1, we have to add here. So in case of year is earlier, year is same cases, okay. Year is earlier, but it is happened 2017, it is happening in the 2018. That time what we do? So directly we can add the 15. Okay. So in case year is latter, 2019 it was happening. So 1st January blindly we can add to this AESTDTC. Means the first day of the month.
Hi, Shiva.
Yeah.
Yeah. So if you are saying the year is earlier, right?
Yeah. Year
So
is
if
earlier.
year, yes, so if the year becomes earlier, then it goes into medical history, right?
No, no, no. What happened? So screening time is there. For example, 2017 onwards, the screening is ongoing. The study was started, but screening was going on. So
Okay.
immediately they are not taking. So screening is ongoing. Screening before anything was happen, as you said, it go to the medical
Okay.
history. Okay.
Okay. Got it. Yeah. Thank you.
Yeah.
Yeah.
So year is latter. So first of that month. So in case of only the year is present, month and day both are missing. Okay. Just understand the scenario. So not go to the depth of coding. So only the year part is present, month and day both are missing. So in that cases, what they do? So this year part is less than the actual treatment start date. So what they do? So directly we can add the month and day from here and we just replace here. You can see the screenshot 2017, go to the 2017 March 2nd. So in that cases, M should be the flag because month and year both are we are replacing month and day. So if the year is greater than, so 1st January directly we blindly add to this year. So if the year is same cases, we have to add the plus one to the day and we replace the January 3rd here. Okay. In case of adverse event end date cases, if only the year is present, okay, so we can take the this March and to here. If it is a year is greater than 31st of January, year is less than December 31st. Okay. So only the day is missing. What we need to do? So last day of the month. We already discussed how to calculate, how to input the last day. Simply we can use the intnx function to derive. In case of only the day is missing, last day of the month. If the only the year is present, so we can take this information and replace here. So completely missing. So no imputation were done most of the times. If the year is not available, so most of the statistician are not suggested to input something. Only the date part, month part is missing. So we can do some imputation to fulfill the data. So why the imputation is important? Because so we can't do most of the analysis without a proper data, right? So that is why analysis purpose. So they make the missing values into meaningful date, so that we will get a good results, means good analysis values with the imputed value. Even though in the submission team we will inform to these are the imputed values, so there is a flag here, DTF flag, so that show which values are imputed, which values are originally collected. Okay. Yeah, these are the 5 interview questions.